What's up, you freaking geniuses? So in this video, I'm going to teach you how to find angles in a right triangle when you're given at least two sides, all right? And we're going to do this using inverse trig ratios. So these types of problems you can basically break down into three simple steps. So the first step is just identifying the angle that you're looking for, all right? So let's just start there. What are we looking for? So we're looking for angle B and angle A. So let's start with angle B over here, okay? So step one is done. We have identified the angle we're looking for, angle B. Now, let's identify the sides of the right triangle. So what I mean by that is let's identify the opposite side, the adjacent side, and the hypotenuse. Okay, so let's start with the hypotenuse. That's normally the easiest one to identify just because it's always on the opposite side of the right angle. So if the right angle's up here, that means the opposite side must, or the hypotenuse, sorry, must be on this side over here. Okay, so this is the hypotenuse. Now, the opposite side of the angle that we're looking for over here, angle B, is just going to be directly on the opposite side of this angle, right? So you can just draw a straight line from your angle to the opposite side. So that means this side over here is the opposite side, right? And then by process of elimination, that means this angle this side right here must be the adjacent side, right, to angle B. Okay, cool. So now that we have the three sides labeled, now let's figure out what trig ratio we want to use, sine, cosine, or tangent. So in this case, as you can see, we're given two sides, right? We're given the adjacent side and we're given the opposite side. So what trig ratio uses the opposite side and the adjacent side? Well, that would be tangent. Okay, and a helpful little way to remember that is by using SOHCAHTOA. So maybe that's an acronym that you've heard, or maybe it's not. But SOHCAHTOA is just SOHCAHTOA. So you use sine when you're given the opposite side and the hypotenuse. You use cosine when you're given the adjacent side and the hypotenuse. And you use tangent when you're using the opposite side and the adjacent side, right? So that's why we want to use tangent in this case, because we're going to use the opposite side and the adjacent side. Okay, so we're going to say that the tangent of the angle that we're looking for, right, angle B over here, right, angle B is equal to the opposite side over the adjacent side, right? So what's the opposite side? 2. What's the adjacent side? 3. All right, so we put a 3 on the bottom. Okay, so this is the little equation we're going to solve. The tangent of angle B is equal to 2 over 3. Now here we're just trying to solve for angle B, right? That's what we're looking for. So how can we solve for angle B over here? Well, we need to get rid of this tangent, right? And we can't just like divide by tangent, right? That doesn't really work that way, unfortunately. So what we're going to have to do instead is take the inverse tangent of both sides, right? So the inverse tangent looks like this. So it's basically the tangent raised to the -1, right? That's what it looks like, but it's called the inverse tangent. So we're going to take the inverse tangent of this side over here, of the tangent of angle B. And in algebra, what you do to one side, you do to the other, right? So we have to take the inverse tangent of this side also, all right, of 2/3, right? So of 2/3. Okay, so what ends up happening here, some math magic, this inverse tangent and this tangent cancel each other out. And so then all we're left with is angle B, all right? So all we're left with here is angle B. And that's equal to the inverse tangent of 2/3, right? So you simply have to plug this into your calculator to solve for that. And depending on the calculator you're using, it's going to be a different button for everyone here. One way you can probably get to it though is by just pushing the tangent button twice, okay? Or you could push the second button and then the tangent button. One of those two methods are probably going to work. Okay, so if you plug this into your calculator, you'll get that angle B is approximately 33.60 nice, all right? So this is what angle B is right here. And we can round that. Let's just round that to the 10th place. Let's just say 33.7, just to make it a little bit easier, all right? So awesome. Now we know what, let's clean this up a little bit. Now we know what angle B is, right? We just found it. It is 33.7 degrees, all right? Now the last thing we have to do is find angle A. So we could use a trig ratio to find angle A, or the quicker way of doing that is by just remembering that when you add up all three angles inside of any triangle, they add up to 180 degrees, right? So if we know that this angle, the right angle, is 90, and we just found this angle, right, 33.7, well, we could just say 90 plus 33.7 plus angle A, whatever that is, has to be equal to 180. Okay, so 90 plus 33.7 is 123.7 plus angle A is equal to 180, right? So then here we can see that angle A must be equal to 56.3, and that's degrees, right? And down here also. So angle B, 33.7, angle A is 56.3. And that's degrees, right? And down here also. So angle B, 33.7, angle A is 56.3. All right, let's try one more here. So as you can see, we have another triangle, right triangle, triangle X, Y, Z, and we're given these two sides. This is 3 and this is 9, right? So again, we're just trying to find the angles inside of this right triangle, right? Angle X and angle Z. So in this case, let's just look for angle X, right? So this is the angle we're looking for, right? That's step 1. Step 2 is identifying the three sides, okay? So first of all, we can identify the hypotenuse, right? Looks like it's this long side right here. This is the hypotenuse, okay? If you draw a straight line from the angle to the opposite side, that gives you the opposite side over here, right? And then again, by process of elimination, this side over here must be the adjacent side. Also, that makes sense because adjacent just means next to, right? So that's why this side is next to this angle, right? So now that we identified all three sides, let's figure out what trig ratio we want to use. So the two sides that we're given are this one, the adjacent side, and this one, the hypotenuse. So what trig ratio uses the adjacent side and the hypotenuse? Well, that would be cosine, right? So remember, so ka oa, right? So adjacent and hypotenuse, right? Adjacent and hypotenuse. So we want to use cosine in this case, right? So here we're going to say the cosine of the angle that we're looking for, and in this case it's angle X, right? Angle X is equal to the adjacent side over the hypotenuse. So the adjacent side is 3 and the hypotenuse is 9. Okay, so again, we're trying to solve for angle X, so we need to get rid of this cosine, right? And again, we can't just divide both sides by cosine. What we have to do instead is take the inverse cosine of both sides. So we're going to have the inverse cosine of this side over here, right? So of cosine angle X, and that's going to be equal to, again, what we do to one side, we do to the other, right? So we have to take the inverse cosine of this side also of 3/9, all right? 3/9. Okay, so again, the inverse cosine and the regular cosine just cancel each other out. So then we're just left with the angle of X. All right, so angle X is equal to, and then here, if you plug this into your calculator, you'll get that angle X is equal to approximately, and I'll just round to the 10th place, 70.5 degrees. All right, so cool. We found one of these angles right here. So now we know that angle X is 70.5 degrees, right? Now to find angle Z, again, we can just add all three angles up and set them equal to 180, all right? So we have this one that we just found, 70.5. The right angle is 90, and the missing one is angle Z, and that's equal to 180. Okay, so then solving for angle Z over here, we'll get that angle Z is equal to 19.5 degrees. Boom. So if you found the video helpful, definitely leave a thumbs up down below. And if you have any other questions or want to see any other examples, just let me know in the comment section below.